Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to find the cube roots of a complex number. I say the cube roots because a complex number has 3 cube roots. Hopefully you'll remember that from the lecture videos. So we have 4 times the square root of 3 plus 4i, and we're going to be finding the cube roots of this number. So let's go ahead and start by calling this number z. So z is our complex number, 4 root 3 plus 4i. So we're going to start by writing this in polar form using Euler's formula, and then we're going to go ahead and cube root it. At the end, I'm going to show you a graph. So we're going to start by finding the absolute value of z, which you can also call r. Remember, r is the modulus or the absolute value, and it can be found by the formula. If z is equal to a plus bi, then its modulus is going to be the square root of a squared plus b squared from the Pythagorean theorem. So we're going to do square root of 4 root 3 squared plus 4 squared. 4 root 3 squared is going to be 48, and 4 squared is 16. Their sum is 64, 64. And the square root of 64 is 8. So the absolute value of z is 8, and then we're going to go ahead and take the 8 out. If you want to write some complex number in polar form, you can actually do that by taking the r out, because remember, in polar form, r is kind of like all the way on the outside, and inside we're going to have everything divided by 8. 4 root 3 is going to become root 3 over 2, and 4 is going to be 1/2, so that when you distribute, you're going to get the same thing. Make sense? Now this is nice, because take a look. This represents modulus, which is r, and this represents cosine theta, the argument, and this number here, and this number represents sine theta. So we're basically looking for a number or angle whose cosine is root 3 over 2 and whose sine is 1/2 at the same time. You could also look at tangent. If you divide sine by cosine, that gives you 1 over root 3. But remember, there are 2 angles between 0 and 2 pi whose tangent is a given number. So that's why you have to be careful about the coordinate system and where this, in which quadrant, yes, that was the word I was looking for, in which quadrant. And we're in the first quadrant because everything is positive. So now here's the cool part. Once you find theta, you can write this as r times e to the power I theta. This is the most compact form, and thanks to Euler, this is an awesome, unbelievable, amazing formula. But what is the theta, right? Think about it. Cosine theta is root 3 over 2 and sine theta is 1/2. If you know your special triangles, you'll say, hey, theta is supposed to be 30 degrees or pi over 6 radians. That's what theta is. It's unique. So we can go ahead and write this as 8 times e to the power I times pi over 6. So that's our z in polar form, a very compact form indeed. Now, the next step is going to be finding the cube roots of z. So there are 3 cube roots, and we're going to call them w0, w1, and w2. Okay? I kind of went over this in the lecture notes, but I realized that it was kind of confusing, so that's why I wanted to go over this with an example. So w0 is going to be the first cube root, which uses the original z. What do I mean by that? So we're going to basically cube root this number. How do you cube root a number? You just cube root it. Easy, right? 8 times e to the power I pi over 6. So here's what you need to do cube root this. You're going to go ahead and cube root the 8, which is going to give you a 2. And when you raise e to the power I pi over 6 to the power 1/3, it's going to be multiplied by 1/3. Therefore, it's going to give you e to the power I times pi over 18. Make sense? That is the first cube root. Now, once you find one of the cube roots, which I guess you could call principal, right? Then you can get the other ones just by thinking about the following. These are going to be 2 pi over 3 apart. Why is that so? Let's go ahead and take a look. Now notice that if you add 2 pi to an angle on the circle it's going to bring you to the same point. Let's say we start here. Add 2 pi, that's going to bring you to the same point. So I might as well just add 2 pi to this. But what is pi over 6 plus 2 pi? You can think of it as pi over 6 plus 12 pi over 6, which is 13 pi over 6. Makes sense? So that's going to be our second angle. Of course, it's the same angle, but I added 2 pi. But isn't that the same thing? Yes, but when I cube root it, it's going to be a different angle. Makes sense? So when I cube root it, it's going to be 2 times e to the power I times 13 pi over 18. And then I'm going to add 2 pi again. Now this time you're adding 12 pi over 6. That's going to give you 25 pi over 6. Don't worry, I'm going to show these to you on the graph. And the cube root is going to be 2 times e to the power I times 25 pi over 18. You see how we go from 25 pi over 6 to 25 pi over 18? I multiply the angle by 1/3. Easy, right? That's all you have to do, cut in thirds. So, one thing to notice, because we added 2 pi every time, but then multiply by 1/3, these are going to be 2 pi over 3 apart. In other words, the cube roots of a complex number are equally spaced on a circle, which I'm going to show you in a little bit. And they're always going to be equally spaced. So the whole circle is 2 pi radians. If you are dealing with cube roots, divide that by 3, and you're going to get the increment. So in other words, cube root the modulus, and then add 2 pi over 3 to the smallest angle, and you'll get the next one. And then do it again. If you do it one more time, that's going to bring you back to W0 because it's a cycle. Make sense? So you don't have to do it again. There's only 3 cube roots, and they are unique. So let's go ahead and take a look. Oh, by the way, could I write these in standard form? And answer is absolutely. For example, what about W0, right? W0 is 2 times e to the power I times pi over 18. Remember that? But what is pi over 18? Pi over 18 is 10 degrees. So you can write this as 2 times cosine pi over 18 plus I sine pi over 18. As far as I know, correct me if I'm wrong, you're not able to find a radical expression for the cosine and sine of pi over 18. Basically, we can't find it. Makes sense? I couldn't find the radical expression. You can find cosine 36. You can find some other values, but I don't think there's a value for cosine 10. Please correct me if I'm wrong. But the other ones similarly can be written just by replacing the pi over 18 with the other angles. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.